Welcome to my project bazaar.com. Here we are going to discuss about the implementation of fixed and floating point square root using non-restoring algorithm on FPGA. In this project mainly focused on variable precision fixed and floating point operation have various field of application including scientific computing and signal processing. Field programmer gate array are a good platform to accelerate such application because of their flexibility, low development time and cost compared to the application specific integrated circuits, and low power consumption compared to the graphic processing unit. Increasingly, scientists are interested in variable precision fixed and floating point operation, not limited to single or double precision operations limited on FPGAs, in order to make those operations more resource efficient and more suited to their own applications. Among those operations, the square root can differ based on the algorithm implementation. They can highly affect the total performance of the application running time. There are two main methods to represent a numeric value in a computer. One is fixed point format and the other is floating point format. The difference between these two methods in that the former one has the radix point which has a fixed location to separate the integration fraction part of the numeric values. The floating point format has three parts to represent the numeric value: the signed bit, the exponent and the matrix. The advantage of using the floating point format is that floating point can represent a wider range of values than fixed point format when using the same number of bits. The floating point format has been standardized and is widely used for scientific computation. The minimize anomalies and improves numerical equalities. In this standard, the arithmetic format of the floating point number is defined as follows. We define b as the base, which is either 2 or 10. Uses the sign bit. E is the exponent and C is the matrix. The corresponding bit is the signed exponent of the matrix for each format. Notes that 3 or many combinations of not included in attributes that FPGA like and still accomplish the accompanying tasks. In order to implementing floating point reciprocal division and square root components, these are three parts of the floating point number to consider based on the previous introduction of floating point representation, which are sign bit, exponent and matrix. The computation method of sign bit and exponent is based on the operation implementation and straightforward. For reciprocal, the sign bit of the result is the same as that of the operand, and the exponent is the result of separating the operating exponent from 0. For division, the sign bit of the result is the output of XOR logic of the two sign bits from the operations, and the exponent is obtained from the subtraction, and the exponent of the division from that of the division. For square root, the sign bit of the result should be 0. Otherwise, if the operator is negative and exhibition is entered, exponent for square root is the flow function of the half operand exponent. In this black diagram represent the flow of our process. In our project, we give the input signal to the input generation. We give the single clock signal. In our process, we are going to generate the FIR filter with the help of fixed point and floating point. Then finally we pass it into our input generation output pass it into the divider. The divider separates our fixed point and floating point matrices. Then next we subtract the two values and finally add and subtract. Then final subtraction is thing. Then finally we get the output. These outputs are get our FIR filter. Finally, we get our accurate values from the circuits. Now, we are going to discuss about the running procedure of our project. In our project, we have 4 steps. First step, we check the syntax error. Then second step, we generate the RTL semantic diagram. Then third step, we generate the technology semantic. And then finally, we generate the simulation waveform. Now, we are going to the first step. First, select implementation. Then select main function. Then select check syntax. In this process, we check the syntax error of our program. In case of any error and warning that displayed in our console log. Now we have no error. Therefore, we are going to the second step. Please select view RTL schematic and run that. Now We are going to generate the Addons schematic diagram. After running procedure complete, select add, create schematic. This is our overall Addons schematic diagram. This is our internal Addons schematic diagram. Now we completed 2 steps. Now we are going to the third step. Select view technology schematic, then add, then create schematic. This is your overall technology schematic diagram. This is your internal technology schematic diagram. This internal technology schematic diagram consists of LEDs and flip-flops. Now we completed 3 steps. Finally we are going to discuss about the final step. Please select simulation and select simulate behavior model and run that. Now we are going to find out the square root value. Give any values. If example we give 32-bit, please give the 32-bit values 1 2 3 4 5 1 0 0 0 0 0. Now we give the input at 32-bit. Apply. OK. Now run our program. Now we got our output. We give the 32 now we give the input value 32. Now we got the square root value 5. It is based on the round of conditions. Now we completed our running procedure. Thank you.